Hello and welcome all. Greetings from Team Bob the Builder. Today we will have a video session or a screen share session of the live webinar 2 which is conducted. This is basically related to Staad Pro Session 2 in which we are going to focus on structure wizard and property assigning, support, adding the sections, assigning the sections, etc. Okay, I will just give you a brief recap of the session 1. In the session 1, we basically focused on geometry part, creating a geometry, modeling it, learning various types of editing commands such as translational repeat, rotational repeat, mirror, etc. How to connect to members, add nodes, and how to see different type of views from various axes, what are the types of axes, important thing, y-axis is the vertical axis, etc. etc. So I think you must have gone through the session 1. If you haven't gone through my webinar session 1, I strongly suggest you that you should go through the webinar session 1. Otherwise, today this video or this screen share video will be little difficult for you to understand. So today we are going to start with first open the Staad window. I'm just opening the Staad window. Then I already created a file webinar 2. Or for your reference, I will go for new project, closing this, go to space, put webinar 2. That's my new file name. I already selected the file location. My units are also selected, meter and kilonewton. Click on next. Now, since we are going to start with structure wizard, there are options here. You could just go with the previously taught option, which is add beam, or you will directly open with open structure wizard. So click on open structure wizard, then click on finish. You can see a different window is opened. This is the structure wizard window. In this, there are various types of modules available. It's a predefined modules. There are truss models, frame models, etc. etc. Today we are going to just focus on the frame models. Since our competition is based on steel structure, I don't think so. The rest of the modules such as solid or plate models are useful to you people right now. So I will suggest you to just focus on frame models as well as truss models. So now here click on double click on bay frame. A new window will appear. In this, he will ask for different parameters. He is asking length, height, width. So basically, what is a length? Length is nothing. Length is the dimension along x-axis. Height is the dimension along y-axis. Width is the dimension along z-axis. Then here is the option of number of bays. So the first option you can see number of bays is 4. So what does it mean by number of bays? Number of bays is like number of partitions. So basically that 12 meter length will be divided into 4 parts. You could see, you could change this bit. I'll just click on apply. You could see that structure here. Can you see that structure here? But it's a little complicated structure for you to start with. So again, I'm clicking on bay frame. I'll be putting length as 10 meters, number of bays as 2 bays, height as 15 meters, fine. Okay, even now I will put height as 6 meters, number of bays along height will be 2 again. Width, okay, width will be 12 meters and number of bays will be 2. Now click on apply. See, this structure looks quite simple to you people right now. So we'll deal with this structure. Are you getting this? Now we want to import this structure into the main Staad window. There are options available. You could just say, there is one option here, file. There is merge model with Staad Pro model. So you could click here or just close this structure wizard window. Staad will ask you a question. Would you like to transfer or merge this model prototype into Staad Pro? Say yes. Now we'll ask for some reference. So what is this exactly? This is like, would you like to, overlap or coordinate? Basically, this is like coordinate system. In this coordinate system, Staad is asking particularly, okay, would you like to coincide 0, comma 0, comma 0, but basically origin of the prototype structure wizard model to the origin coordinates in this main Staad window? Say yes. Okay. Now your structure is ready here. Now we'll go to geometry. See, we have already created this number of nodes in just 1 second. So we have created around 27 number of nodes in just by structure wizard. We don't need to type everything now. So this is the efficiency and the power of structure wizard. Okay, now we'll focus on general. Go to general tab, which is just below the geometry. There are some sections available. Firstly, what we'll do is we'll assign the supports first, because it's a very easy part. Okay, now what we'll do is we'll assign the support later. First, we'll define the properties and add some sections. We'll assign the sections also. So since we are already in the property tab, property space supports, these are sub tabs basically. So since we are already in the property tab, go to section database. There are a lot of actually options available for you people. Either you could define the section or you could go to section database. Firstly, we will look into section database. What is the section database? So just click on section database. After clicking on section database, a new window will appear like this. In this, you could see there are section databases of various countries and various codes available here. So in that particular, choose Indian. Okay, in Indian, there are various shapes of steel sections. See here, we have chosen the material as steel. So it will show steel sections only. S shape, I shape, M shape, etc. Angle, वगैरह. So now we'll choose some angle sections. Okay, angle sections. I'm just choosing angle sections of 40. Okay, I will go with 40 by 45, 5. So click on add. As you click on add, a new section is added here. Can you see this section here? Okay, great. Now again, I will add one more angle section, a little more with the cross section. I'll put 60 by 60 by 6. Great. Now I am adding few channel sections. I'm adding ISMC 150H, add, and at the same time I'll add ISMC 250. And so close this section profile tables window. You can see you have added 4 sections. So you must have a question. Why I added only 4 sections, or why 4 sections, not just 1 section? I'll just answer this question in a minute. Firstly, we'll create groups. If you remember, I taught you how to create groups in webinar session 1. So to create group, just put Control G. You can see here a group name and define group name window will appear. I'm just closing this window again. But before creating the group, tell me, why should we create the group? See, groups are created basically to assign of same type of members, same type of beam section, so that we can select all those members at once and assign their properties and different restraints just by clicking or adding, assigning that particular restraint and property to the entire group. So it actually saves our time. So before creating the group, we'll decide which are the groups we are going to create. So basically, I will suggest you to create 4 groups. In this particular model, I can see 4 groups here, which is outer columns. Outer columns means these columns, the columns on the boundary. So there are basically 8 outer columns, and then we have one internal column also. Sorry for the interruption. We will proceed with the video again. Okay, so we were like about to create groups. So I will suggest you four types of groups basically. Groups of edge columns, which are outer columns on the boundary. Groups of this one internal column. Groups of the beams on the edges, and a group of these internal beams. So now you understood the four types of groups. Put Control G. First group we are creating is columns sorry for the spelling mistakes. Columns underscore external. Select type as beam. Click on OK. See, the group is created. But as you can see, beams are unassigned. Create another group. Columns underscore internal. Beam. OK. Create another group. Group name. Beams external. Select type as beam. Click on OK. Create the fourth group. Beams underscore internal. Okay, so the four groups are created, but no beams or no members assigned to any of the groups. So now we will assign the members to each group one by one. First we will select the internal column here. Okay, after selecting the internal column, we are selecting that internal column into this main geometry window. Okay, so the entire internal column is selected. Now go to here, assign methods, associate to selected geometry. Associate. Great job. You can see beams are assigned. Now what we'll do is, we'll select the external columns. So now how will you select the external columns? Okay, I'll show you a way. First here, external. Then go to select beams parallel to Y. But since this central column also is a beam parallel to Y, that also will get selected. So either you could do is deselect it. Just deselect it. Put control and deselect it. Can you see it's done? So again go to associate, selected geometry and associate. Now we want to select the external beams. Okay. I'm just shifting this create group. Just look into my window. Now go to select beams parallel to X. Select beams parallel to Z. So all the beams are selected, but we don't want those internal beams. So what we'll do is, we'll go to the top view and we'll deselect these beams. I'm just deselecting it. Again we will go to isometric. You can see only edge beams are selected. So associate to selected geometry, associate. Now put on beams internal. Then again go to top view and select the internal beams only. Check in isometric view. All internal beams are selected. Go to associate. Okay, can you just again we'll check each and every group is assigned properly or not. So go to columns external, go to highlight. Okay, only external columns are selected. Beams external, highlight. Great. So we've done the pretty job with this. Okay. We're just shifting this window here, there, nothing else. What we do. Okay, so 4 groups are created, 4 sections are added here. So we'll be assigning each section to each group. So firstly, select ISA 40 by 40 by 5. We are going to assign this angle section to the outer beams. Beam section is selected. Click on highlight. Here, the section is also selected. Now there are options also assigned to selected beams. Select this option. Click on assign. Staad will ask, do you want to proceed? Say yes. Great. So the section is assigned to the corresponding members. Now go to beams internal. Click on highlight. Again click on, no, first click on the section. Then click on highlight. And I'm assigning ISA 60 by 60 by 6. Just click on assign. Say yes. Done. So now we'll go to ISMC 150H. This section is I'm assigning this section to outer columns. So columns external, highlight, click on assign. Say yes. Now the last section, I'm assigning ISMC 250 channel section to the internal column. Click on highlight, click on assign. Yes, done. So all the sections are signed. How can you check whether all sections are signed or not? Just firstly close the create group window. Now we will check whether every section is assigned properly or not. Just go to rendered view. Can you see this pyramid icon here? Okay, click on that. You can see here. This is the rendered view. Can you see this rendered view here? Okay, I'll show you the rendered view. Can you see here? These are the channel sections at the columns, and these are the angle sections at the beams. So basically, the 3D view which you're seeing shows that how your structure is going to look like. I'm closing the rendered view. Now we will proceed in adding something. What we will do is we will add a dome over this. Are you getting my point? Okay, before adding the dome, I will just go to support. Here, property. There are sub tabs. In those sub tabs, there is one tab of support. Just come to the right hand side of your window. Here is the option of create. So I'm just creating a fixed support. Fixed support means it has all 6 degrees of freedom restrained. So all 6 things are restrained. No movements allowed along any axis. No deformation along any axis. So all 3 directions, displacement as well as rotation about all the axes are restrained. So I'm just adding a fixed support. Great. Now what I will do is I will go to the front view. I will select the support first. Then I will select the nodes to whom I want to assign this support. See, I have selected just the bottom nodes. Can you see all 9 nodes are selected? Now there is an option assign to selected nodes. Just click on assign. Say yes. Okay, the supports are also assigned. Till now it's very clear. Now what we'll do is I will show you something which you can do for a fun, as well as to understand the structure wizard and the reference coordinates well. Firstly, we'll go to geometry window. We'll go to node cursor. Click on this node. So what are the coordinates of these nodes? 5, 6, 6, right? Okay. So what I want to do is I want to save this first. I want to insert want to place a dome on the roof. See, can you see this is the roof or the roof slab of the structure. So I just want to insert a roof onto this just for some fun purposes, not some structural purpose. So what I want is I want the center of the dome should be this point. So that's why I'm getting the coordinates 5, 6, 6 should be the center of the dome. And what should be the radius of this dome? See, I will go to the top view. Now I'll go to the top view. Wait. I want such a dome that it should fit within this. So what is the length of this members? I will calculate the length also. You know how to do it? Go here, display node to node distances. Just click on this. Okay, I will show you how to do it. I'll just click here, display node to node distances. Then I'm clicking on this. Okay, so this is 12 meter as we have defined it. And this is 10 meter as we have defined in the structure wizard. So what I want is, I want a dome of maximum size to such that it should fit within this 12 by 10 rectangle. So what should be the ideal diameter of that dome? Obviously 10 meters. So the radius of that dome will be 5 meters. But I'll show you how to do it. Go to again this. Go to again geometry, then structure wizard. Go to surface or plate models. Here is the option of spherical surface. Click on that, double click on that. There is option spherical cap. So spherical cap. What is the diameter you want of the sphere? I want the diameter of the sphere to be 10 meters. Great. And what the base diameter? Okay. So what is the difference between the base diameter and diameter of the sphere? See, diameter of the sphere is what we want as a 10 meters, but base diameter could be different. Base diameter is like a sphere can have different shape, different cross sections. Like a sphere can be cut into various sizes. Like one could be hemisphere, one could be a smaller, some section smaller than hemisphere, one could be a section greater than hemisphere. So according to that, you need to specify the base diameter. So consider that a flatter sphere. If the sphere is a quite flatter sphere, obviously the base diameter will be lesser than the original diameter of the sphere. So right now I'm just putting it as I need my base diameter to be 10 because that's the maximum base diameter I can fit in my roof. Okay, I will rest of the things keep it as same and just apply. See, can you see this? Wait, can you see this? Can you see this sphere? This is the hemisphere. In this, what is happening is this lower circle, this has a diameter of 10 meters as well as the diameter of entire sphere is also 10 meters. So the base diameter means diameter of this lower circle and diameter of sphere is what we consider as 10 meters right now. We can change this. Again, what we'll do is we'll increase the diameter of the sphere and see what happens. I'm putting as 15. So I will get a flatter one. See, can you see this? So the diameter of the sphere is increased, but the base diameter is same. Okay. Again, we'll go to and we'll have diameter as 10. So again, we'll get hemisphere. Okay, there are some issues. Wait a minute. Wait a minute, I'm just cancelling this and closing the structure wizard. Now it will ask to merge it, but I don't want it merged. So I'm just closing everything. Again, we'll go to structure wizard. We'll go to solid and plate models. Again, we'll go to sphere. Put top diameter of sphere is 10. Base diameter also 10. And click on apply. So this is the hemisphere you're getting. Now we want to place this hemisphere at the top, at the roof of that structure existing. Just close and click. Say I want to merge the model. Now, what should be your coordinates? See, we just checked it. It should be 5, comma 6, comma 6. Just click OK. Can you see this? I'll show you in your front view. We have placed that dome above the particular frame which we have created in the structure wizard itself. But this is the 10-meter side. We will see the side view. In the side view, because it's a 12-meter side, the dome has some margins on the side, in the side view. We'll see it. We'll go to rendered view. It will show a nice 3D view. Can you see this? Wait a minute. Okay, can you see this? Great. So this point I'm talking about. I will just zoom it up. This point is talking about. So this point is actually the center of this sphere. So while putting the coordinates of the reference point, which we have put in 5, 6, 6, we were shifting the center of the sphere from 0, 0, 0 to 5, 6, 6 so that it will properly fit on the roof of the structure. Again, we'll go to general. Okay. Now what we'll do is I will delete this sphere because we are not going to decide any kind of spherical structures which is a concrete structure or a plate element. So I'm just delete the structure. But to delete this, we need to go with the plate cursor. See, the entire dome is selected. Just put delete. Again, our frame structure is ready. Again, check the rendered view. This is fine. Now we'll go with the loadings. Various types of loadings. We assigned supports, we assigned sections. Now we're clicking on remove all node-to-node distances so that all the distances that this figure was showing were removed. Now there's one more sub-tab, loads and definition. So go to loads and definition. Go to load case details, click on that, click on add. Click add first load case. That should be your dead load. Add. Again add live load. Add. In this we're just going to deal with the dead load and a live load. If there is anything such as wind load or something we are dealing with, we will deal with in the third webinar most probably. Or we will deal with the wind loads or any kind of lateral loads in our transmission tower webinar. So particularly for this structure, we are only dealing with dead load and live load. So click on add. Unfortunately load case 3 is also added. Just click on close. Click on load case 3 and say delete. Yes. Now click on load case 1. Say add. You can see a new different window. In that there are options: self-weight, nodal load, member load, physical member load, area load, etc. I'm just considering this as a frame, steel frame structure, not any kind of slab or any floors or anything like that. So I'm not going to go into member of area load, floor load right now. Self-weight. See, every member have its own self-weight. So what we need to do is we need to assign the self-weight by a multiplier factor here. See, self-weight always acts in the vertically downward direction, which is a negative y direction in the case of Staad. So that's why we are selecting the axis, which is a direction, and we are selecting the multiplier. Say click on add. So self-weight is added. Save. Suppose there is something called member load. Uniform, you consider that each your beams is having some kind of uniform member load, or they're having some kind of partition walls over it. So we'll assign some kind of, wait a minute, member load. Okay, we are assigning member load as uniform load as 3 kilonewton per meter. Click on add. Great. Since in this case of load case 2, which is a live load, click on add. We will add few nodal loads. In this particularly, so we are applying nodal loads at some nodes. So we will apply on some 3 nodes, like in the directions, fx as 10 kilonewton, as well as fz as 20 kilonewtons. Click on add. Now close. Okay. So for cell fit, just click the cell fit. There is an option here, assignment methods. So click on assign to view. When you click on assign to view and click on assign, this load case is assigned to the entire structure, because we are assigning cell fit to the entire structure because every member have its own cell fit. So cell fit should be assigned to every member. Now click on uniform load. This will be assigned only to beams, not columns. So to do that, go to select beams parallel to X, select beams parallel to Z, and assign to selected beams. Here is the option assignment method. In assignment method, click on assign to selected beams and click assign. Yes, you could see a uniform load type icons are coming here, particularly on each members. Can you see? I will show you in front view. Can you see this? Oh, unfortunately what happened is we assigned plus 3 kilonewtons, which is in vertically upward directions. So we will change it. Don't worry about it. We'll go to that. We'll click on edit. We'll put here minus sign. So click on change. Close. Now again go to the top view. Can you see the difference? I'll just zoom it out. Okay, can you see the difference? Now it's acting vertically downward as we wanted it. Great. Now what we'll do is we will apply this particular nodal loads to all the outer nodes of the top roof. So I will show you how to do it. I will go to node cursor. I will select all the nodes where I am going to apply this load. I will just select 3 nodes, okay, at one time. We will see that. Can you see that? I just selected these 3 nodes, and again I'm selecting this case and say assign to selected nodes. Click on assign. You could see the differences. Can you see that? Can you see this? The loads are applied here on this node. On in this direction particularly, one which is X direction, and this direction is Z directions. Great. Now we'll go to load envelope. Click on add envelope. Firstly save the window and click on add. Then just keep it none. And say add envelope. Close. So envelope is added. Can you see that? Envelope is added, envelope is also added. Load envelope is nothing but a load combination. So till now we assign loads also. We assign loads to some nodes, loads to members and self-weight. But how to check that which member has assigned which load, which node has assigned which node, which member has which properties section assigned to it? This is a simple method. Go to beam cursor, click on any node and just double click on the member. You could see here geometry. It will show you two nodes by which the member is defined. First node, second node, coordinates of that node. Again it will show you, go to property, it will show you, okay, this is the angle section assigned to this. There are various properties of that angle section. You could also change the properties here. You can see material here. And finally the loading. You could see load case 1, uniform load of 3 kN per meter is applied to it. Can you see that? Load case 2, nothing is applied to it. Great. Close. Similarly, we will look into a node. Can you see that? Nodes. Node 9, you could see coordinates. You could see loads which are applied 10 kN in positive x direction, 20 kN in positive z direction. Then again we will close this window. Wait a minute, I'm closing it. Okay, now again we will go for these nodes. Can you see here nodes, load, no load is okay. In this also we applied 10 kilonewtons and 20 kilonewtons, as you can see here. You can see here support. Node 1 has a support. Node 10 has a these nodes have supports also. Can you see that? I'm just closing the windows. Or you could go to geometry. See here. This is a node table. You can see every node table, etc. Similarly, just go to beam table, zoom it. You could see material applied, properties, which property section is applied, beta angle, length, everything. So node is here, everything is here. So again, go to geometry. So your structure is ready. Oh, by some means we added a node here. So we will delete this node. How to delete this node? We'll merge the members. I'm just selecting those members to merge. Okay, go to geometry. Go to merge selected members. Merge. Okay, the extra node is deleted. Similar thing has happened with this also by some means. Go to geometry. Merge selected members. Okay, great. So your structure is ready, your geometric model is ready, you assigned the sections to it, you have assigned the support reactions also, you also defined the loading conditions also. You can see here your loading conditions here. So what now? We are ready for the analysis of the structure. But before analysis, we will look into some theory and analysis and design part. We are going to look that part into our webinar session 3. So see you in the webinar session 3. I hope you have understood whatever I taught today. I'll just give a brief recap. Today we have just learned how to use a structure wizard, how to assign properties, how to create properties, section database, how to create supports as well, how to define loads and definitions, etc. And finally, how to check whether which member is applied with which properties, sections, etc. and support reactions, any nodal loads, etc. So we are all set for the analysis and design of the structure. We are going to look into this section in webinar session 3. See you all there. Till that, I will just have few instruction, last minute instruction for you people. Practice a lot. If you have any queries, feel free to message me or post it on a Facebook page, which is Bob the Builder 2.0. You could send a mail at Bob the Builder 2.0, Bob D Builder 2.0 at gmail.com, or you could message on our WhatsApp groups, etc. But feel free to ask your doubts. Don't hesitate. We are always ready to help you people. I hope you are already installed the software. Everything is running fine. You're understanding the session. You're working nicely. You're practicing a lot. Gear up for the competition. Okay. See you in the webinar session 3, which is the final session of the Staad Pro regarding Staad Pro and steel design. After that, we will have 2 special webinars regarding transmission tower or telecom tower design. So see you in that. Thank you. Bye.